Hey everybody, welcome to Systems Expert. Let's dive into the question.
Hi Clement. Today I want you to design Netflix.
Okay, Netflix. So from a high level, Netflix seems like a pretty straightforward service. Users go on the platform, they're served video content, movies, TV shows, they can watch this video content. Is this what we're designing, the high level, overarching Netflix product, or do you want me to focus on particular subsystems of Netflix?
We're just designing the core Netflix product, as you said. So the overarching system that you described.
Okay, so then just to clarify, there are a lot of auxiliary services that are a part of Netflix, like for instance, authentication. Users can create an account, they can log on, they can pick a profile or the payment service. Users can subscribe to Netflix and pay with their credit card. Do I have to worry about those auxiliary services, or can I kind of gloss over them or even skip them altogether?
You can ignore those auxiliary services. Focus on just the primary user flow. That being said, one thing to note is that by nature of the product, we're going to have access to a lot of user activity data that's going to need to be processed for the recommendation engine. So you're going to need to come up with a way to aggregate that user activity on the website and be able to process it into, say, a set of scores for the content.
Okay, so you're saying that we're going to want to also kind of enable some sort of recommendation system, and this is something that operates what in the background, maybe asynchronously. Is that correct?
Yeah, that's correct.
Okay, and it consumes this user activity data that we're gathering from users.
Yeah.
Okay. Okay, so then I think that I think that it makes sense to divide this entire system into two major subsystems. The first one would be the core user flow. I'll write this down, the core user flow. And what I really mean by that is anything that involves like videos. So, storing videos, streaming videos, and I suppose I might, also tie in storing user metadata and static content like, video descriptions and things like that. That'll be one part of this system. And then I'm thinking of having the second part, which would be the recommendation engine or system. So I'll write it down, recommendation engine. And this one it'll be kind of tangential to the core user flow. Does this make sense as a high level overview?
Yeah. But just to clarify, the core user flow, as you described, is the main system for which we care about latencies, right? So that's the video streaming system. The recommendation engine, though, on the other hand, you don't care about latencies as much because, as you said, it happens in the background.
Okay, so you're saying that for the core user flow, we're going to care about latencies, which makes sense because users want to stream video basically in real time, very fast. And I'm assuming we also care about high availability for this system. Are we also designing this at a global scale, or is this only for a specific region? Or
Yeah, let's talk global in this particular case, and also highly available for the core user flow.
okay, so I guess what I'll put here is I'll maybe put an arrow. We care about latencies here. Latencies. Maybe I'll put fast latencies, and we care about high availability. And this is a global audience. But for the recommendation engine, like we said, it happens in the background.
Yep.
Availability. Okay, so and I suppose global audience. Global audience. How many users do we expect to be using Netflix?
So Netflix, I can just tell you this. Netflix has about 100 million to 200 million users. So let's just go with 200 million as a conservative estimate.
Okay, so 200 million users, and I suppose I can assume that they're spread out across the globe kind of equally.
Yeah.
Okay, and then one last question that comes to mind is people can use Netflix a lot of different clients. Like people can use Netflix on their desktop computer, they can use it on their tablets, on their phones. Do you want me to design this system specifically for these clients? Like, do I have to optimize for, let's say, mobile clients or?
So even though, yeah, Netflix is used by all sorts of clients, don't focus on that. Just focus on the distributed systems aspect. We don't need to get into the detail of the clients.
Okay. Okay. So then in that case, I think that we can get started. And I think that, like I said, I'm going to divide this into these two subsystems, the video aspect and the recommendation engine. Maybe we can start with the video aspect or the core user flow that's tied to the video aspect. And so for this, I guess I should first decide what we're going to store, like what data we're going to store. I think that, like I mentioned before, there's going to be, maybe let me write down data. There's going to be video content. There's going to be user metadata, which I mentioned before, user metadata. And this is going to be, I'm thinking like whether a user has watched a video, whether a user has liked a video, because I think you can rate videos on Netflix. Maybe how much of a video a user has watched, that kind of data. And then I think there's going to be static content. Like static content, this is going to be stuff like the names of movies and shows, maybe their descriptions, thumbnails, maybe like the cast of a particular movie, that kind of stuff. And then I think we might have also a fourth type of data, because for the recommendation engine, you mentioned that we're going to be gathering a lot of user activity. I don't know if what I have in mind for user metadata here is like quite exactly the user activity data that you were describing. So I think that we might on top of user metadata gather much more granular like user events, like literally any click on a video, that kind of stuff in the form of logs. Does that make sense?
Yeah, let's do that. And there's going to be a lot more of that than just the user metadata, like ratings and progression that you mentioned.
Okay, yeah. So then I'll just capture then this fourth piece of data as just logs, and we could throw in anything that we want here. Any type of granular event we can just throw into these logs. But for now, I think I'm going to skip the logs section for a little bit because that kind of ties back to the recommendation engine. And I think we can start with these three pieces of data, which are more relevant to that core user flow. But so if we do a little bit of estimation for how much storage we're going to need, because I guess we have to figure out what storage solutions we're going to go with. Let's start with a video. So for the video, I guess Netflix doesn't have that many movies, right? This is not like a service like YouTube where any user can upload basically an unlimited amount of video content. Netflix has a very like limited amount of video content that's picked by them. So I think, is it fair to estimate that Netflix has like, I don't know, 5,000 movies?
So let's go with something slightly bigger than that. Let's go with 10,000, just to be safe in terms of our estimates.
Okay, so I'll put 10,000 then. I'll put it in blue. So we've got 10K movies, 10K videos, let's call it that. And we need to store 10K videos. Now, videos, if I remember correctly from Netflix has multiple like different resolutions for videos, right? Or video qualities. Like you can, and I think that there are different subscription plans. Like you can see videos in standard definition, high definition. I forget if they've got like 4K or something. So we need to store every video in all those resolutions, right?
Yeah.
Should I assume that we've got 3 resolutions, or which ones should I assume?
Let's just go with standard and HD.
Okay, so standard and HD. So I'll put 10K videos. We've got standard definition and high definition. Let's see. A video on average is probably like an hour in length because we have movies that are up to 2 hours. We have TV shows that are just like 20 minutes per episode, 30 minutes. So let's go with an hour as an average video length.
Okay.
An hour of video in standard definition is probably like, I don't know, I would say like 10 gigabytes per hour. 10 gigabytes. So 10K videos that are 1 hour average. And then I think 10 gigabytes per hour for standard definition. And HD would be like double standard definition, like 20 gigabytes. Does that seem like a fair approximate?
Yeah, that's reasonable.
Okay. So I'll put 20 gigabytes per hour. And here, what I'm really saying by per hour is like each hour of video content takes 20 gigabytes in HD and 10 gigabytes in SD. So that means like 30 gigabytes for every single video. Mm-hmm. And if we've got 10K videos of 1 hour each, so let's say 10K multiplied by 30 gigabytes, that is, let's see, 300,000 gigabytes, right? Because 100, yep. So 300,000 gigabytes. 300,000 gigabytes. Let me remove one of those commas here. And 300,000 gigabytes is 300 terabytes. So this isn't actually that much data. Like, I was expecting quite a bit more, because you think of Netflix and you think that it's almost like purely video content, and so they're going to have to store a ton of data. But this seems actually pretty low. Like, compared to something like YouTube or Google Drive, I feel like this is considerably lower. This is very, very palatable. So I'm thinking that we don't need to optimize or do anything like super fancy with our video storage solution, and we can probably get away with just storing our video content in like a blob store like S3 or GCS. Does that seem reasonable?
Yep, 300 terabytes is super palatable.
Okay, so then maybe I'll write here the first storage is going to be, let's go with S3, Amazon S3, and this is going to be our video storage. So video storage, and this would probably be replicated maybe across regions or something like that. And I suppose we'll get into the actual serving aspect of this video content in a little bit, but that's what I'm going to go with for storing the video content. Then there's user metadata and static content. We said we'll do logs later. For the static content, I think that we can probably like static content is relevant to videos, right? So there's no more like there for every video there's static content. And static content is just text, so it's going to take up way less storage than video. So I guess this static content is bounded by 300 terabytes, I think. And it's nothing super fancy. So I think we can probably store this in either some sort of like key value store or maybe a relational database like Postgres. So I think I'm not going to put too much effort into this. Does that make sense?
Yeah.
Okay. But then for the user metadata, I think that we can also try to estimate, because now I'm starting to think if this video content takes only 300 terabytes, we might actually have more user metadata than video content, because we've got 200 million users. So maybe we're going to have to do something for the user metadata. Let's try to estimate it. Mm-hmm. So we have 200 million users. We're going to be storing user metadata about these 200 million users probably per video, right, at the video level. Because this user metadata, I said, is going to be something like whether a user has watched a video. So that would be kind of like a Boolean. How long or how much of a video they've watched. So how many videos do we estimate a user will watch in their lifetime? Because we're trying to estimate like how much storage we need just for all of user metadata across all of Netflix, in perpetuity. So let's assume maybe that a single user watches, I don't know, one video or two videos a week on Netflix, 2 shows. If a user watches 2 shows a week, let's say 50 weeks in a year, there are 52, let's round it down to 50. So 100 shows per year. Let's take an average, a lifetime for a user of like 10 years on Netflix, because Netflix has only been around for 20 years. So let's take 10 years, 100 shows per year. That's 1,000 shows in a lifetime. So we're going to be storing per user 1,000 like user metadata on 1,000 videos. Now, how big is this user metadata? It doesn't seem like it's that big. Like if it's the thing, like whether it's watched and how long of the video has been watched, we're talking in the order of bytes, like 10 to 100 bytes per video. Does this seem kind of accurate, or are you thinking that we might have more user metadata?
Yeah, let's go with 100 bytes per video per user, just because we don't know what kind of overhead we might have with the storage medium.
Okay, so let's do 100 bytes then. 100 bytes per user, or per video, sorry, and there are 1,000 videos per user, we said, in a lifetime. So 100 bytes times 1,000, that's going to be, what, 100 kilobytes? 100 kilobytes per user, I guess. And then we have 200 million users, so 100 kilobytes multiplied by 200 million. That's what that is. 1 gigabyte. 1 gigabyte multiplied by 20,000 multiplied by 20K. So that's like 20 terabytes. 20 terabytes. So we're gonna have 20 terabytes of user metadata. So we are, like I said, in the same order of magnitude as with the video storage, or the amount of space that the videos take. So that's interesting. Again, the reason I'm surprised is because I was thinking that Netflix is a video streaming platform, so video is going to take up a ton of space, but I guess it's just not like YouTube or Google Drive where you can upload an unlimited amount of video. All that being said, I do think that for this user metadata, we can probably just store it in a relational database like Postgres, because we're likely gonna want to query this data pretty often, right? At the same time, let's see, do we want to do anything fancy there? I'm thinking that for Netflix, right, you go on the platform, a user might update their user metadata in the background, or we might need to request the user metadata. But I feel like anything that is latency sensitive won't be an expensive operation to run, right? It'll just be like read user metadata from the database. On the other hand, anything that might be expensive, like compare user metadata across a bunch of different users and all that stuff, that would only happen like if you were running some kind of analysis in the background. Like imagine a systems administrator were running an analysis on all of Netflix user metadata or something like that. So what I'm getting at is because Netflix users are by nature like isolated, and Netflix users are the only people for whom we care about fast latencies, I think that we can just shard whatever like relational database stores this user metadata at the user ID level. So like imagine we have here, a relational database, let's say Postgres, for our user metadata. I think that we can probably shard it, into a few shards, maybe, I don't know, like 5 to 10 shards. That way each shard has 2 to 4 terabytes of data, and these shards would be based on the user ID. Does that make sense?
Yeah.
So I'll put just sharded at or based on user ID. Based on user ID. And then for the static content, like I said, this static content, I think we can just put in another relational database. So maybe I'll add here. This is going to be static content in a relational database. Okay, so that is really the storage aspect. I guess it's, like I said, it's less complicated than I was expecting. What I think will be complicated will be actually streaming or serving this data, and not the static data, and not the user metadata, but the video data. Because the core Netflix service, right, is being able to watch videos, and like you said, we care about very fast latencies globally. And if we've got, let's see, 200 million users, maybe it might make sense to try to estimate like our bandwidth consumption at any given point in time, and to see like how much how much data we're gonna need to serve. Does that make sense? Should I do that?
Yeah. Yeah. Yeah.
Okay. Okay. So I'll write this down here. So let's see. We've got 200 million users, right? 200 million users. They're watching videos. I suppose they're not going to be all watching at once. We can assume probably that during peak time, maybe 1% of Netflix users are watching a show. Maybe like if there are shows that are very viral, super popular, maybe we've got 5% of the global Netflix user base watching like video at once. 5% would be what? Like 10 million if we're 5% of 200 million?
Mm-hmm.
Yeah, so 10 million. So we're going to assume like 10 million is the peak traffic. 10 million users is the peak. And if we've got 10 million users watching a video in, let's say, high definition, just to be conservative, that means 10 million users need 20 gigabytes per hour. So 20 gigabytes per hour is how many gigabytes per second? Let's say that there are 4,000 seconds in an hour, just to round things up and make things easy to calculate. So 4,000 seconds in an hour. So 20 gigabytes divided by 4,000 is 5 gigabytes divided by 1,000. So 5 megabytes per second. So 5 megabytes per second. And this is per user, and we've got 10 million users. So 5 megabytes times 10 million, so times 10 is 50 megabytes, times a million, you add 6 zeros. So it is 50 terabytes. So 50 terabytes per second bandwidth consumption. Does that seem accurate, like as the peak amount of bandwidth consumption that we might expect on the Netflix service?
Yeah, you just should be big B for 5 megabytes per second, but yeah,
Oh yeah,
I think that's reasonable.
yep, Mbps. So okay, so 50 terabytes per second. That I'm not like super well versed in video streaming and all of that, but that seems like a lot. That seems like something that is not handleable by a single data center or even a few data centers. So I think that we're going to really want to spread out this load across probably like a ton of machines and even more specifically a ton of locations, right? Because you don't want, it's not about a single data center having a bunch of machines, because that's still like one bottleneck at the data center level as far as bandwidth goes. We want this to be spread out over or across a bunch of different locations. So I think that what we can do, what comes to mind would be to use a CDN for the video serving. We can use a CDN like Cloudflare, and the CDN, the key point is that it has to have a lot of points of presence, right? A lot of POPs. And these POPs would probably consist of thousands or hundreds of machines. So that way we can bring down, like if we've got a CDN with 1,000 points of presence, we already bring down the bandwidth consumption to the order of gigabytes per second. And if the points of presence have themselves like clusters of machines, then we can bring it down to the order of like megabytes per second. And then the CDN is what basically allows this insane amount of video content to be consumed by so many users at once. Does that make sense? Is that on the right track?
Yeah. Yeah, that looks good. How do you kind of make sure that the point of presence have the right data locally?
Yeah, so you definitely need some caching, because you don't want to have to always, like, you don't want requests to just have to then grab the video content from our blob store, because then you're back with the same issue. So let's say we have our CDN. I'll put the CDN here. So you've got CDN here, and it's got a bunch of POPs, points of presence, and you've got users here. Maybe I'll write them in white here. You've got users who are requesting videos from our CDN. Our points of presences here, or our points of presence, have to have video content cached. And so what I'm thinking is that we can have like a service that lives in between the CDN and the blob store that basically asynchronously populates these pops with the video content that they need to have. So you can imagine that if Netflix is releasing new movies, then this service, let's call it like a cache populator, will make sure to have these new movies get sent to these points of presence, and it can probably like prioritize important movies, deprioritize unpopular movies. Does that kind of make sense?
Yeah.
Okay, so then I'll just write this here. We'll have a cache populator. Yeah, so this is, I think, how we're going to achieve this is going to interact with this and with our blob store. And I think this is how we achieve the video streaming and this really high bandwidth consumption.
Okay. This is perfectly reasonable. It turns out Netflix in real life solves the issue by partnering with internet service providers themselves. So instead of using a classic kind of CDN, they partner with the Verizons and the AT&Ts of the world and inject a special caching layer crafted by Netflix at locations that are called Internet Exchange Points, IXPs. And these are kind of the counterpart to the point of presence for CDN. And there's thousands, tens of thousands of them across the world, if not more than that. And so it behaves essentially like an optimized CDN, which allows for much cheaper bandwidth for Netflix, and the users obviously have much lower latency as well.
Okay, so it's like an optimized, like much more specialized version of what I described here.
Mm-hmm. Exactly.
Okay, cool, good to know. But so then I think this probably wraps it up for the core user flow, where I suppose we need to talk about how we're actually going to be updating the user metadata and even getting the static content. So here I think in the same way that we have users who are requesting video content from the CDN and from the blob store eventually, we're probably going to have a layer of API servers here. So I'll put like API servers, and we've got our users here who are requesting, they're requesting static content and user metadata from our API servers. We're probably going to have some load balancing happen beforehand. So the load balancing here, I guess we can probably do like round robin load balancing for all of our requests. Maybe we can already load balance at the user ID level, because we said that all of the user metadata that a user is going to want is going to be specific to them. So maybe it makes sense to have our load balancer here load balance according to user ID. Or if not, if we just go with round robin, then our API servers here will then go to the appropriate shard based on the user ID in the request. So it's nothing too fancy here. I'll just write load balancer. One thing I did want to say is that if we're dealing with just 20 terabytes of static content, we can probably cache our static content in memory at our API server level. So we probably don't even need our API servers to go to the static content database. Like they only need to go maybe every so often, when maybe like every day the cache gets updated or something like that. And to be honest, even for the user metadata, I'm wondering if we could do just caching at the API server level, in which case we would have to do the user ID based load balancing, but some sort of like write through cache policy. Does that make sense?
Yeah.
Okay. So I'll just put maybe caching layer here. And at this point now, I do think that we've taken care of the core user flow. So I think that now we can move on to this recommendation engine. Is that okay, or do you think I'm missing something?
No, I think we can move on to that. That makes sense.
Okay, so for that, I guess let me give myself a bit of space here. We said that we might want to gather more granular user activity, so like logs. And I'm thinking that these logs, they're going to be things like, I guess, does it make sense? Do you think that it makes sense to have these logs be what gets fed into our recommendation engine? Or maybe not necessarily the recommendation engine, but the system that backs it. Like, we have some sort of MapReduce job that asynchronously consumes all of these logs that are stored somewhere and then spits out some sort of more meaningful data that is used elsewhere in our system. Is that kind of like what you had in mind for the recommendation engine, or is this something else?
Yeah, so that is what I had in mind, but I'd like more detail on number one, how you store the logs, like where they should be stored, what technologies to use, and then what the map function, reduce functions might look like. I'm not asking necessarily for what the truth is and what Netflix exactly does, but just an idea as to what you could do.
Okay, so since we're going to be performing MapReduce jobs on this data, we're going to need a distributed file system. So I think we can store our logs in a distributed file system like the Hadoop distributed file system, HDFS. And basically, like if these are our users here, they're sending logs all the time that get stored into let's call it HDFS. And then we've got this asynchronous MapReduce job that takes the logs from the HDFS and actually, processes the data, those logs. So if those logs look like, let's see, a log would be kind of like raw data, right? So a log might look like, it has a user ID that points to, let's say, UID1, right? It's got maybe an event type, like this would be something like pause or click on the screen or mouse move, whatever granular event Netflix thinks might lead to meaningful like data, something that can predict engagement or that kind of stuff we want to track. So event, this would be probably like an enum, just put like type in capital letters. And then probably the video ID, right? Video ID. And here I'm sure that we might store, I'll put vid ID 1. I'm sure that we might store other stuff in these logs, like maybe the region or other things, but this would be like the core values that I would expect in these logs. Does this make sense?
Sure. Yeah.
Okay, and so if these are the logs, they're stored in the HDFS, then we feed them into our map function.
Mm-hmm.
So our map function takes these logs as inputs, and then it probably aggregates them at the user ID level, because you said that this is a recommendation engine. You said that we probably want to spit out like a score or something for the user or for each video. So I think that it makes sense to aggregate, to have the map function output intermediary key value pairs that are like based on the user ID. So it'd be something like, let's see, like this goes into the map and the map spits out something like, user ID, or not even user ID. It spits out the key is the user ID. So like UID1, and this maybe is a list of tuples where the tuples are like the video ID and the type. This would be, vid ID 1 pause. Then it would be, let me give myself a little bit of space. It would be vid ID 2, vid ID 2 play. We're just kind of making up the events here, but you get the idea, right? So you've got all of these key value pairs that are indexed at the user ID level, and you've got all of the events with the relevant video IDs for each user. And then that gets fed into our reduce function, right?
Mm-hmm.
And our reduce here, I don't know exactly how this might work in a real system like Netflix. I'm assuming that they might have, machine learning models that are getting trained on this intermediary data, or, some sort of data pipeline that grabs the data in the middle of the reduce function. But eventually you might spit out, the final score that you were looking for. So this might be something like a user ID pointing to a video and a score, or maybe it might be a user ID pointing to like a stack ranking of videos. Like, let me write it down here. You might have UID 1 pointing to V1, V1, V2, V3, right? Or you might have UID 1 pointing to V1, like a tuple V1 comma score. And here you would have a bunch of these scores with each video ID. So basically what I'm getting at is, depending on your use case, depending on what your data science department might be looking for, depending on what data you think is meaningful for your recommendation engine, you could write your reduce function in various ways. Does this make sense?
Yeah, no, I think this is a reasonable kind of approach.
Okay, so then that is the recommendation engine that I can think of. And I think that that kind of captures everything that we wanted to build here.
Yep, sounds good. Thanks, Clement.
With that, I hope that you found this video informative, and we'll see you in the next one.